Hey guys, Mr. Backberg here. In this video, we're going to look at simple harmonic motion. So as we're talking about harmonic motion, what we're talking about is tracking the movement of an object that either rotates, oscillates, or vibrates. And we can look at those things algebraically and graphically by using either a sine or a cosine equation. So a point moving on a number line is in simple harmonic motion if the directed distance d from the origin is given by either one of these sine or cosine equations. Now in these equations we need our a and our omega variable to be real numbers, and we need omega to be greater than 0. If we want to find the frequency, then what we're going to do is take that omega value and divide it by 2 pi, and that's going to tell us the number of oscillations per unit of time. So we could talk about it as oscillations per second or rotations per minute, something along those lines. So let's say we attached a weight to a spring. When we do so, the weight stretches the spring out, but then it eventually compresses back down, and it continues this behavior. And let's say that it takes 4 seconds in order for this weight or this ball to complete this motion. So then we can use one of our sine or cosine equations to model the behavior of this ball. So we're going to go d equals, now for that a value, we're going to look at the displacement of our ball, the movement of the ball. So as we look, it's going down a distance of 10 centimeters, but as it springs back up, it goes up a distance of 10 centimeters. So that a value in front is going to be 10. Now we need to decide if we're going to use a sine or a cosine. Because we started kind of in the middle at this equilibrium point, I'm going to use a sine equation. Now as far as finding that omega value, we talked about the frequency as being omega over 2 pi. And because the period is 4 seconds, it takes 4 seconds to complete this cycle, that would mean that the frequency is 1 over 4. So now I can do a little cross multiplying in here. I can take omega times 4, and I can take 1 times 2 pi. Solving to get omega alone, I would divide that 4 over to the other side. So my omega value is pi over 2. And I have to multiply that by t. So this sine equation is going to model the behavior of this ball or this weight on the end of this spring. Now in this example, we're taking a look at a wheel that has an 8 centimeter radius, and it turns with an angular velocity of 8 pi radians per second. And the first thing we want to figure out is what's the frequency in cycles per second. So the first thing I want you to think about is making one full rotation around, but in terms of radians. And we've said that one full rotation is 2 pi radians. Well, this rotates 8 pi radians per second. So if one full rotation is 2 pi, then this wheel is making 4 rotations every 1 second. So we can think about that as being the frequency of this wheel spinning, or the behavior of this wheel spinning, 4 rotations per second. Now the next thing we want to find is our distance from the starting point, which happens at a time of 0, exactly 3.45 seconds after starting. And in order to do this, we're going to need an equation. Now, because our wheel has an 8 centimeter radius, that means the maximum height and the minimum height is each 8. So my a value is going to be 8. Now, as far as thinking about whether we're going to use a sine or a cosine, I want to think about laying this out on a grid. And we're looking at this wheel, and at a time of 0, we're going to start at the maximum distance away from the origin. So because of that, we're going to use a cosine equation. Now in the previous example, we found out that our frequency was 4 rotations every 1 second. So if I think about finding that omega value, we take omega over 2 pi to find the frequency. If we do some cross multiplying, 1 times omega is omega, and 4 times 2 pi is 8 pi. So that omega value is going to be 8 pi, and then we're supposed to multiply that by t. Now, if we're trying to find the distance from the starting point at a time of 0, then what we're going to do is we're going to plug in 2 separate values into our equation. And the first value that we're going to plug in is that t value of 0. So if I plug that in for my variable within the equation, we should get a distance of 8. Then we want to look at what happens at a t value of 3.45. So if we then plug in 3.45, we're going to end up getting approximately 2.47. So then if we're trying to find this total distance from the starting point, we would take our initial starting distance minus that distance after the 3.45 seconds have elapsed. So if we subtract these, 8 minus 2.47, we should get about 5.53, and we're measuring this distance in centimeters. So we're a little bit more than 5.5 centimeters away from our starting point. That's going to be it for this video. Thanks for watching.